That's to the second one. Now in this case, the angle is 90 degree plus theta or pi by 2 plus theta. Let's divide the circle into 4 equal partitions with the help of x-axis and y-axis. So this is the x, O, x dash. This is y, O, y dash. This is point O. Let's say this is the point P. Now what we need an angle which is 90 degree plus theta. So from here we will go up to this point. This is 90 degree. We know that right angle equals 90 degree. 90 degree plus theta. So the point will lie somewhere over here. So this is the point P corresponding to the angle. Theta 1. Corresponding to the angle theta 1. Where theta 1 is basically what? 90 degree plus theta. 90 degree plus theta. Okay. After this, to obtain the values of sine theta 1, cos theta 1, we need to drop a perpendicular from P to obtain the triangle of reference. So we will drop the perpendicular from P on x-axis to obtain the triangle of reference. Now let's relate this triangle of reference with the earlier triangle that we have made for the angle theta, because we want to reduce this theta 1 into the angle theta. So for theta, we knew that the point was somewhere here. Let's this point be N. This angle was theta, this was y, and this distance was x. Now from here we know that it is 90 plus theta. So this angle is going to be theta. So if this angle is theta, this particular angle, which is angle POM, it is equals to 90 degree minus theta. So we can say that triangle OP and an OPM are congruent triangles. Since these triangles are congruent, so here we have y in front of theta. So this angle is going to be theta. So in this triangle, the side opposite to theta is actually OM. So this will be y, and here this angle POM. POM is 90 minus theta. And here this angle will be 90 minus theta. So the side opposite to 90 minus theta is x. So here the side opposite to 90 minus theta will be x, this way. So this is x and this is y. Now, for this particular point P, the triangle of reference is POM. So if I need to write the value of sine theta 1, it will be algebraic distance of this point P from x-axis upon radius. So algebraic distance would be plus x. Why? Because we are above the x-axis. So it will be x upon r, plus x upon r. But from this triangle, we know that in terms of theta, x by r represents what? Cos theta. So sine theta 1 is equals to cos theta. What is theta 1? Replace it. Theta 1 is basically 90 degree plus theta. So sine of 90 degree plus theta will be equals to cos theta. Similarly, if we talk about cos theta 1 would be algebraic distance of this point P from y-axis. So this distance will be y, but we are in left side of y-axis. That is in negative direction of x-axis. So this distance will be minus y. So cos theta 1 will be minus y upon r. Or we can write it as minus times y by r. But from here we know that y by r is equals to sine theta. So it is minus sine theta. So basically cos of 90 degree plus theta is equals to minus of sine theta. Cos gets converted into sine. It becomes sine theta, and there we have to put a minus sign. Just like that, we can discuss about 180 degree minus theta, or you can say pi minus theta. let's divide this circle into 4 equal partitions with the help of x-axis and y-axis. This is x, this is O, this is x dash, this is y, O, y dash. Now 180 minus theta. So we'll go up to 180 and then we'll do minus theta. So somewhere here we will get the point. So let's say here we have the point P. This is 180 minus theta. So this angle over here is theta in this case. And this particular angle is theta 1. This particular angle is theta 1, where theta 1 here represents 180 degree minus theta. So to obtain the triangle of reference, we need to draw perpendicular from P on x-axis. So let's compare it with the previous triangle. The side opposite to theta was y and the side opposite to 90 minus theta was x. So this is y and this is x that we know. Alright. Now let's talk about sine of theta 1. Sine of theta 1 would be algebraic distance of point P from x-axis. So we are above x-axis, so this distance will be y only. It will be y upon r. But we know that in terms of theta, y by r is equals to sine theta. So sine theta 1 is equals to sine theta basically. So sine of theta 1, which is 180 degree minus theta, is equals to sine of theta only. For example, sine of 120 degree can be written as sine of 180 degree minus 60 degree. 120 degree can be split as 180 minus 60. So this is sine of 180 minus 60, and we say that sine of 180 minus theta is equals to sine theta only. So it will be equals to sine 60 degree only, which is equals to root 3 upon 2. So the value of sine 120 degree is plus root 3 upon 2. This is how we can apply the formula. Let's talk about cos. If we need to find the value of cos theta 1, then cos theta 1 is basically algebraic distance of this point P from y-axis. So the distance would be OM, but we are moving in negative direction of x-axis, so we'll take this x with a minus sign. So it will be minus x upon r, or we can write minus times x by r. But in terms of theta, we know that x by r is cos theta, so it will be equals to minus cos theta. So from here, we can say that cos of 180 degree minus theta is equals to minus cos theta. For example, cos of 120 degree can be written as cos of 180 degree minus 60 degree. But we know that cos of 180 minus theta, cos of 180 minus theta is equals to minus cos of theta, that is minus cos of 60 degree. The value of cos 60 degree is 1 by 2. So the answer is minus 1 by 2. So the value of cos 120 degree is basically minus 1 by 2. Is that clear? So from these above illustrations, what we have concluded that for doing reductions, from here we have concluded that while doing reductions, we need to take care of two things. First is whether trigonometric ratio gets converted, because in some of the cases sine gets converted to cos and cos gets converted to sine, but in some of the cases sine remains sine and cos remains sine, and this happens with all of the trigonometric ratios as well. So first point, we need to take care whether the trigonometric ratio gets converted or not. Second, whether a plus sign or a minus sign. We need to take care when the plus sign will come and when the minus sign will come. So on the basis of these two things and some observations, we are going to decide a rule with the help of which we can reduce any larger angle into smaller angle. So let's discuss that particular rule for reduction. So the rules for reduction. Rule for reduction. with the help of this rule, you can reduce any larger angle into smaller angle. Let's write down the values over here. We'll start from here. This is 0. I'm going to write the values in radians. So we'll add 0 and pi by 2. If we'll add pi by 2 to 0, we'll reach to this point, and this point will be pi by 2. Again we'll add pi by 2 in pi by 2. Pi by 2 plus pi by 2 is pi. We reach on this line, which is pi. We'll add pi plus pi by 2. We'll do pi plus pi by 2. We will get 3 pi by 2, and we will reach here. 0, pi by 2, pi, 3 pi by 2. These are called quadrant angles. After adding pi by 2 and 3 pi by 2, I will get 2 pi. This is also a quadrant angle. So all the angles along these lines are called quadrant angles. Now, the story doesn't end here. We'll again add pi by 2 in 2 pi, and we'll receive 5 pi by 2. We'll obtain 5 pi by 2. Now add pi by 2 in 5 pi by 2, you will get 3 pi. 3 pi will be over here. Again add pi by 2 in 3 pi. You will get 7 pi by 2. Again add pi by 2 in 7 pi by 2. You will get 8 pi by 2, which is 4 pi. Again add pi by 2 in 4 pi. You will get 9 pi by 2. Now add pi by 2 in 9 pi by 2. You will get 5 pi. Similarly, here you will get 11 pi by 2 and then 6 pi. And this thing goes on like this only. So here you can observe that on this line we get even integral multiples of pi. On this line we get odd integral multiples of pi. On this particular line we get odd integral multiples of pi by 2. This line is considered as horizontal line, and this line is considered as vertical line. So this is horizontal line and this is vertical line. This particular line, this line, I'm drawing it with some waves. This wavy line is called as change line. We need to take care of two things only while doing reductions. That is whether trigonometric ratios get changed or not, and secondly what we need to put, a plus sign or a minus sign. So we are answering the first question. This line is change line, and this line, the vertical line, is the change line, and the horizontal line is the no change line. This is the no change line. Now what is the meaning of change line and no change line? Change line implies that whenever we will cross this particular line, the trigonometric ratio will get changed. So if we are doing pi by 2 plus theta, we know that we take positive angle if we are going in anti-clockwise direction. If we are going in anti-clockwise direction, then plus theta. Remember this thing. And if we are going in clockwise direction, we'll take minus theta. So from here, if I'm going in my anti-clockwise direction, I will take pi by 2 plus theta. And if I am going in clockwise direction, I will take pi by 2 minus theta. So pi by 2 plus theta, pi by 2 minus theta, or 5 pi by 2 plus theta, 5 pi by 2 minus theta, or 3 pi by 2 plus theta, 3 pi by 2 minus theta. I'm crossing this particular line. So the trigonometric ratios will get changed. And how will they change? They'll change according to the rule that sine and cosine will get interconverted, tan and cot will get converted, sec and cosec will get converted. Correct? And no change line implies that sine will remain sine, cos will remain cos, tan will remain tan, and same with the other trigonometric ratios. So first part, we have got the answer for the first part. Let's talk about the second part. For the second part, you know this, that in the first quadrant, all are positive. In the second quadrant, sine and its reciprocal are positive. In the third quadrant, tan and its reciprocal cot are positive, and in the fourth quadrant, cos and its reciprocal are positive. So with the help of this rule, let's try to solve the questions. Say for example, we need to find the value of tan 120 degree. Now there are two ways. Why? Because 120 degree is less than 180 but greater than 90. So it will lie in the second quadrant. But to reach the second quadrant, we have two ways. Either we will do pi by 2 minus theta, pi by 2 plus theta, or we will do pi minus theta. By doing pi by 2 plus theta or pi minus theta, we can reach this second quadrant. So I can write it like this. Tan pi by 2 can be written as 90 degree. So it's tan 90 plus 30, or it's tan 180 minus 60. Now look over here. 90 lies on the vertical line, which is the change line. So in this case, tan will get converted to cot and we will get cot theta. Here theta is 30 degrees. So we will get cot 30 degree. But now we have to decide whether we should put a plus sign or minus sign over here. For that purpose, we will see tan and the quadrant. Quadrant is the second quadrant. 90 plus theta we are doing. So we are in the second quadrant. So in second quadrant, we know that tan is negative. Why? Because in this quadrant, only sine and its reciprocal are positive. So tan is negative over here. So we will put a minus sign. So it will be minus cot 30 degree. Cot 30 degree is √3. So the answer is minus √3. Let's do this way. Tan 180 minus 60. 180 is pi. So pi is on the horizontal line, which is no change line. No change line implies that tan will remain tan. So it will be tan theta, that is, here the theta is 60 degree. We just have to put the value. We don't consider the sign minus or plus over here. So we'll take only 60 degree. So it's going to be tan 60 degree. But whether it is going to be plus tan 60 degree or minus tan 60 degree, that will be decided by tan and the quadrant. Tan, the quadrant is second again. So tan is negative in this quadrant. So we will put minus over here. We know that tan 60 is √3. So it will become minus √3. So in both the cases, you're obtaining same answers. But we have followed different methods. So this is how you can reduce. Let's take some other examples. Let's take the question. Sine of minus 5 pi by 3. Sine of minus 5 pi by 3. So whenever you get a negative angle, first of all, use the relations. Minus theta relations. Let's discuss them. This was 0. And when you do 0 minus something, 0 minus theta, you are in the fourth quadrant. In the fourth quadrant, we know that only cos and its reciprocal, sec, are positive. So if I'm doing cos of minus theta, then I'm doing basically cos of 0 minus theta. Now 0 is on the horizontal line. Horizontal line is no change line. So cos will not get changed and it will become cos theta only. But we are in fourth quadrant, and in fourth quadrant cos is positive. So we will get a plus cos theta over here. Let's talk about sine of minus theta. Again, minus theta is 0 minus theta. That implies we are crossing horizontal line. When we are crossing horizontal line, the trigonometric ratio doesn't get changed. So sine will remain sine. So it will become sine theta only. But in the fourth quadrant, sine is negative. So we have to put a minus sign over here. And similarly, you can write it for other trigonometric ratios also. Let's do it. Sec of minus theta. It will be sec theta only. But in fourth quadrant, since secant of theta is positive, so we will give a plus sign to it. Let's talk about cosec minus theta. It will be cosec theta only, but in fourth quadrant, cosec is negative, so we will put a minus sign over here. Let's talk about tan of minus theta. It will become tan theta only, but in fourth quadrant, tan is negative, so we will put a minus sign. Similarly, cot of minus theta will become minus cot theta. So these are the minus theta relations. Cos of minus theta plus cos theta and sine of minus theta minus sine theta. So we can use these relations over here. So sine of minus theta can be written as minus sine theta. So it will become minus sine 5 pi by 3. It will become minus sine 5 pi by 3. Sine 5 pi by 3 can be written as, we can split the numerator 5 pi as 6 pi minus pi. And why I have split like this? We have 3 in the denominator. So we need a multiple of 3 which is near 5. So the multiple of 3 near 5 was 6, but 5 is less than 6. So I have written 5 as 6 minus 1. So I have written 5 pi as 6 pi minus pi. Now let's divide it. We will get sine of 3 pi by 3, that is 2 pi, minus pi by 3. Now it becomes 2 pi minus pi by 3. Remind that 2 pi is on the horizontal line. 2 pi is on the horizontal line. Horizontal line is the no change line. So sine will remain sine. It will be sine theta, that is sine pi by 3. But now we have to decide whether to put a plus or a minus sign over here. For that purpose, we will check out which quadrant is this. 2 pi minus something. 2 pi minus something, minus implies we are going in the clockwise direction. So we are in the fourth quadrant. In the fourth quadrant, sign is negative. So we need to put a minus sign over here. So this minus and minus will get plus, and the answer would be sine of pi by 3. Pi by 3 is basically 60 degree. The sine of 60 degree is root 3 by 2. So the answer is plus root 3 by